Section 110.32, titled Working Space, covers electrical equipment. Subsection A, Working Space about electric equipment, states that sufficient access and working space shall be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. However, there are exceptions. Working space shall not be required about the following: firstly, enclosed dead front switchboards that have no exposed live parts; secondly, panel boards having no exposed live parts when all circuit breakers or fuses are in the open position; or thirdly, other equipment where the circuit is de-energized by a positive lockout or other equivalent means. When dealing with a disconnect for an air handling unit located in a closet without sufficient working space, it's important to consider these exceptions. If the circuit can be de-energized by a positive lockout, this is equivalent to the exception in 110.32a3. Therefore, the working clearance requirement of 110.32 is negated when a positive lockout is used to de-energize the circuit. Here are some additional considerations. The door of the closet should be marked with a warning that the equipment is energized and that a lockout must be used before opening the door. The lockout should be applied by a qualified person and only removed by the same person or another qualified person. Regular maintenance and inspection of the lockout system should be conducted to ensure its proper functionality. By following these guidelines, you can ensure that the air handling unit and disconnect are operated and maintained safely while meeting the requirements of the National Electrical Code. Let's delve into a more detailed explanation of each of these points. Firstly, let's address the working space requirements outlined in 110.32a. This section of the National Electrical Code emphasizes the importance of having adequate space around electrical equipment for safe operation and maintenance. The purpose of this requirement is to protect electricians and other qualified personnel from electrical hazards while they are working on or near energized equipment. The specific dimensions of the required working space are determined by several factors, including the voltage of the equipment and the layout of the installation. In general, the working space must be large enough to allow workers to safely access the equipment, perform necessary tasks, and evacuate the area in the event of an emergency. Now, let's consider the exceptions to the working space requirements listed in 110.32a. These exceptions recognize that in certain situations, the risks associated with working on or near energized equipment are reduced or eliminated, making the working space requirement unnecessary. The first exception applies to enclosed dead front switchboards that have no exposed live parts. In this type of equipment, the live electrical components are enclosed within a grounded metal enclosure, which minimizes the risk of accidental contact. The second exception applies to panel boards having no exposed live parts when all circuit breakers or fuses are in the open position. When all of the circuit breakers or fuses are open, the panel board is effectively de-energized, eliminating the risk of electrical shock. The third exception, which is most relevant to the scenario described, applies to other equipment where the circuit is de-energized by a positive lockout or other equivalent means. This exception recognizes that when a circuit is properly de-energized and locked out, the risk of electrical hazards is significantly reduced, making the working space requirement unnecessary. A positive lockout is a procedure that involves disconnecting the equipment from its power source and then installing a locking device to prevent the equipment from being accidentally re-energized. This procedure ensures that the equipment remains de-energized while work is being performed on or near it. Now, let's discuss the specific scenario of an air handling unit disconnect located in a closet without sufficient working space. In this situation, the exception in 110.32a3 can be applied if the circuit is de-energized by a positive lockout. This means that before any work is performed on or near the disconnect, the circuit must be disconnected from its power source and a locking device must be installed to prevent it from being accidentally re-energized. Once the lockout is in place, the working clearance requirement of 110.32 is no longer applicable. However, it's important to note that the use of a positive lockout does not eliminate the need for other safety precautions. Workers should still wear appropriate personal protective equipment such as gloves and eye protection, and they should follow all applicable safety procedures. In addition to the basic requirements for lockout procedures, there are also several additional considerations that should be taken into account. Firstly, the door of the closet should be marked with a warning that the equipment is energized and that a lockout must be used before opening the door. This warning will help to prevent accidental contact with energized equipment. Secondly, the lockout should be applied by a qualified person and only removed by the same person or another qualified person. This ensures that the lockout is properly installed and that it is not removed prematurely. Thirdly, regular maintenance and inspection of the lockout system should be conducted to ensure its proper functionality. This will help to identify and correct any potential problems with the lockout system before they can cause an accident. The warning on the closet door is a critical safety measure. It serves as a visual reminder to anyone approaching the equipment that it is energized and that a specific lockout procedure must be followed before opening the door or attempting any work. The warning should be clearly visible and easily understood. It should include information about the type of equipment, the voltage, and the specific lockout procedure that must be followed. The requirement that the lockout be applied and removed by a qualified person is also essential for safety. A qualified person is someone who has the necessary training and experience to safely perform the lockout procedure. This person should be familiar with the equipment, the hazards involved, and the proper lockout procedures. By requiring that the lockout be performed by a qualified person, the risk of errors and accidents is minimized. Regular maintenance and inspection of the lockout system are also important for ensuring its continued effectiveness. The lockout system should be inspected regularly to ensure that all of its components are in good working order. This includes the locking devices, the tags, and the procedures. Any problems that are identified during the inspection should be corrected immediately. Some common issues to look for during a lockout system inspection include damaged locking devices, missing tags, and outdated procedures. Damaged locking devices should be replaced immediately. Missing tags should be replaced and the reason for their absence should be investigated. Outdated procedures should be reviewed and updated as necessary. By following these guidelines, you can ensure that the air handling unit and disconnect are operated and maintained safely while meeting the requirements of the National Electrical Code. Remember that electrical safety is a shared responsibility. Everyone who works on or near electrical equipment should be aware of the hazards involved and should take appropriate precautions to protect themselves and others. Let's explore the concept of a qualified person in more detail. The definition of a qualified person can vary depending on the specific regulations and standards that are being applied. However, in general, a qualified person is someone who has the necessary training, knowledge, and experience to safely perform a specific task. In the context of electrical work, a qualified person is typically someone who has completed an apprenticeship program, has passed a certification exam, or has otherwise demonstrated their competency in electrical safety. A qualified person should be able to identify electrical hazards, understand the risks involved, and implement appropriate safety measures. They should also be familiar with the applicable codes and standards, such as the National Electrical Code and the Occupational Safety and Health Administration regulation. The responsibility for determining whether someone is qualified to perform a specific task typically rests with the employer. The employer should assess the employee's training, knowledge, and experience, and should ensure that the employee is competent to perform the task safely. In some cases, the employer may be required to provide additional training or supervision to ensure that the employee is qualified. Now, let's consider the specific types of locking devices that are used in lockout procedures. There are many different types of locking devices available, each designed for a specific purpose. Some common types of locking devices include padlocks, circuit breaker lockouts, valve lockouts, and plug lockouts. Padlocks are the most common type of locking device used in lockout procedures. They are typically used to secure disconnect switches, control panels, and other equipment. Circuit breaker lockouts are designed to prevent circuit breakers from being accidentally turned on. They are typically used in conjunction with padlocks to provide a secure lockout. Valve lockouts are designed to prevent valves from being accidentally opened or closed. They are typically used in chemical plants, refineries, and other industrial facilities. Plug lockouts are designed to prevent plugs from being accidentally inserted into electrical outlets. They are typically used in construction sites, manufacturing plants, and other locations where portable electrical equipment is used. When selecting a locking device, it's important to choose one that is appropriate for the specific application. The locking device should be durable, tamper-resistant, and easy to use. It should also be compatible with the equipment that is being locked out. In addition to the locking device itself, it's also important to use a tag to identify the equipment that is being locked out and the person who applied the lockout. The tag should include the date and time of the lockout, the reason for the lockout, and the name of the person who applied the lockout. The tag should be attached to the locking device in a conspicuous location. It should be made of durable material that is resistant to weather and chemicals. Finally, it's important to remember that lockout procedures are not a substitute for proper training and safety precautions. Lockout procedures should be used in conjunction with other safety measures, such as wearing personal protective equipment and following safe work practices. Electrical safety is a serious matter, and it's important to take all necessary precautions to protect yourself and others from electrical hazards. Think of the electrical panel like the heart of the building's power distribution system. Each circuit breaker is like a valve controlling the flow of electricity to different parts of the building. When performing maintenance on a specific circuit, such as the one powering the air handling unit, it's crucial to shut off the corresponding circuit breaker. This is akin to temporarily stopping the flow of blood to a specific part of the body during surgery. The lockout tag-out procedure ensures that the circuit breaker remains off while work is being done, preventing accidental re-energization. Now, imagine the consequences of not following proper lockout tag-out procedures. If someone were to accidentally turn the circuit breaker back on while an electrician is working on the air handling unit, it could result in severe electrical shock, burns, or even death. The lockout tag-out procedure is a simple yet effective way to prevent these types of accidents. The tag attached to the locking device serves as a visual reminder to everyone that the circuit is de-energized and should not be turned on. It also identifies the person who is working on the circuit so that they can be contacted if necessary. The qualified person responsible for applying the lockout tag-out device plays a critical role in ensuring the safety of the work environment. They must be knowledgeable about the electrical system, the hazards involved, and the proper lockout tag-out procedures. They must also be able to identify potential hazards and take steps to mitigate them. The regular maintenance and inspection of the lockout tag-out system are essential for ensuring its continued effectiveness. Locking devices can become damaged or worn over time, and tags can become lost or illegible. By inspecting the system regularly, potential problems can be identified and corrected before they lead to an accident. In addition to the technical aspects of the lockout tag-out procedure, it's also important to foster a culture of safety in the workplace. Everyone should be encouraged to report potential hazards and to follow safe work practices. By working together, we can create a safe and healthy work environment for everyone. The process of de-energizing a circuit involves several steps. Firstly, the qualified person must identify the correct circuit breaker or disconnect switch that controls the power to the equipment being worked on. Secondly, the qualified person must turn off the circuit breaker or disconnect switch. Thirdly, the qualified person must verify that the circuit is de-energized by using a voltage tester. Fourthly, the qualified person must apply a locking device to the circuit breaker or disconnect switch to prevent it from being accidentally turned back on. Fifthly, the qualified person must attach a tag to the locking device identifying the equipment that is being worked on and the person who applied the lockout. It's important to use the correct type of locking device for the application. For example, a circuit breaker lockout device should be used to lock out a circuit breaker, and a disconnect switch lockout device should be used to lock out a disconnect switch. It's also important to use a tag that is durable and legible. The tag should be made of a material that is resistant to weather and chemicals, and the writing on the tag should be clear and easy to read. Once the lockout tag-out procedure has been completed, it's important to verify that the equipment is de-energized before starting work. This can be done by using a voltage tester to check for voltage at the equipment terminals. If any voltage is present, the lockout tag-out procedure should be repeated. When the work is completed, the qualified person must remove the locking device and tag from the circuit breaker or disconnect switch. The qualified person must also notify everyone who was working on the equipment that the lockout has been removed. It's important to follow these procedures carefully to ensure the safety of everyone involved. Here's an analogy to further illustrate the importance of lockout tagout procedures. Imagine a car mechanic working on the engine of a car. Before starting work, the mechanic disconnects the battery and removes the ignition key. This prevents the engine from accidentally starting while the mechanic is working on it. The lockout tagout procedure is similar to this, but it applies to electrical equipment. The circuit breaker or disconnect switch is like the ignition key, and the locking device is like a disconnected battery. By following the lockout tagout procedure, we can prevent electrical equipment from accidentally being energized while someone is working on it. The National Electrical Code provides detailed guidelines for electrical safety. Following these guidelines is essential for protecting workers from electrical hazards. By understanding and implementing the requirements of the National Electrical Code, we can create a safer work environment for everyone. This includes understanding the requirements for working space around electrical equipment, as well as the procedures for energizing and locking out electrical circuits. The importance of these procedures cannot be overstated. They are a critical component of any comprehensive electrical safety program.